you can see, the form dy by dx is the function of x and y. This type of form is just look different from whatever I just mentioned from the first class, right? From the first class, whatever I write down is in this form, which is dy by dx is a function of x only. So if you see the equation like this, it's pretty easy to solve for the solution or the answer, right? But what if we have the equation in this form? How can we solve for the solution of this type of differential equation? What we can do is just that we can rearrange the equation itself into different type of form. We are going to do it into the sixth form. Okay, the first one we call separable equation. The second one we call homogeneous equation. The third one we call exact equation. The fourth one we call linear equation. The fifth one we call Bernoulli equation, and the last one, or the sixth one, we call Riccati equation. So we are going to learn what will be the form of this type of equation that I just mentioned, and then that is the way that we are going to solve. We are going to find the solution for the differential equation. Before we go to the first one, I just would like to tell you that for one equation, it could be in more than one form of equation. So it is up to you that what method or what technique that you want to use to solve for the solution of that differential equation. Okay. Oh, another question. You know, right, whenever we call the first order differential equation, the derivative of the dependent variable would be 1, right? Okay. So now we are going to start with the first order differential equation. Now, for the first part of the form that we are using for solving the solution for the differential equation, we call separable equation. Okay. The definition of separable equation, we just define like this. If we have the differential equation and you write it down in this term, dy by dx is a function of x and y. The one that we call separable equation is that the one that can be expressed as a function of gx, and gx depends only on x. Time is being multiplied with the py has been dependent only on y. Okay, so if you can write down, so simply we put it into this term, this form. If you have two functions that multiply to each other and each function depends on x or y separately, then we define this type of first order differential equation as the separable equation. To find the answer for this type of equation, what you can do is just simply rearrange the equation in such a way that dy go with the function of y and dx go to the function of x, like this. And then since this side of the equation got no x at all, so you can separately integral it. And also this side of the equation has only x variable. So you just can do integral right away because there is no y there. Okay. And again, when you do integral for both sides of the equation, because you didn't put a boundary condition there, so you would plus the constant c. But if the problem gives you the boundary condition, then you should find what would be the value of this. Okay. Here is the example. When you look at this differential equation, can you write this equation in the term of this dy by dx is a function of gx times the function of py. If so, then this equation would call separable equation. Okay? You should, because I taught you this. I am teaching you this type of equation, so the equation that I give you should be separable equation. Okay? Is it a separable equation? Yes, it is, right? Then to find the solution of this equation, we got to write it down. We try to separate x and y out of each other. So we would get what? Dy by dx equals, if you look at the top, the denominator, you would find x, right? You can take it x out. Like this, right? So if we try to put it in the form of dy by dx is equal to gx py, then we would know that gx is equal to x, right? And py is equal to 2 plus y divided by y squared plus 1, right? So is it a separable variable? Is it a separable equation? Is this equation is a separable equation? Yes, it is, right? Then what you got to do next is just that rearrange the equation by put dy with py and gx with dx. So we would get like this. Right? Now, we can do integral for both sides, right? Because now, at our left-hand side, we have y as a function. No, we have function of y with dy. And on the right side, we have x as a function of x, right? Now, how to integral this term, y squared plus 1 divided by y plus 2? How to integral this term? As I told you before, if you have fraction like this, you should make the power of denominator smaller than the denominator. The way that we do is just divide, right? So it just do divide to get the term. So what times y equal to y squared? Y, right? Then we would get y squared plus 2y, right? You do minus. Since the top there, you got no y term. So you would get negative 2y plus 1. Now, what times y equal to negative 2y minus 2, right? 1 minus 4 equal to 5. That's it. Okay? So on the left hand side, you would get y minus 2 plus 5 divided by y plus 2 dy equal to x dx. Then you do integral for both sides. You would get something like this. Plus c, right? So can you integrate it now? Can you do integral for the left-hand side term? Integral has distribution property, right? Y dy minus 2 integral dy plus 5 integral 5 divided by, 1 divided by y plus 2 dy equal to integral x dx plus c. What you get for the first term? To do integral of this, what you get? Y squared over 2, right? And minus 2y and plus 5 ln y plus 2 equal to ln x plus c. Oh, sorry, x squared divided by 2.